Hi guys, welcome back to my channel. In the previous video, we can understood what is a bias and variance are, and we saw that high bias causes a underfitting and high variance causes a overfitting. But today's question is how we do actually reduce overfitting and underfitting in a real model. As in this video, we are fixing a board problem using a coding and graph. We can also visualize that. Yes. Let's start our today's session. First of all, we can take the example of underfitting. Underfitting. After that, we can reduce that underfitting. Yes. In this code, we can import the required libraries like first of all we can import a numpy as np. Second one is matplotlib for visualizing the graph, and third one is we can use a linear regression for that. And let's execute this cell. Yes, now in a second cell, first we can create some data here. Yes, np.line space means we are generating a 50 values between 0 and 10. Yes, then we create the output y. Yes, here I use x square, which means the real pattern is curve. Yes, real pattern is curve. Yes, I also add some random noise to make the data more realistic. Yes, let's execute this cell also. And also we can see what inside X is. See here, 0 to 10. We can see here our data is perfectly sure. We can creating Y axis. We can also perfectly creating X. Yes. And then in the next cell, then we reset X because the scikit learn expected the input in a column format, not in a row format. Yes. We can create here. Yes, we can also see here perfectly. We can create a row into a column. Yes. And in an Excel, we can use a linear regression model. Yes. Here we can use a linear regression model. Linear regression can only draw a straight line. We are training the model using a dot fit. Yes. We can. And this cell is used for plotting code. Yes, this code is for plotting our graph. First of all, we can use to visualizing. First of all, this line visualize properly. We are creating 100 smooth points between 0 to 10, 0 to 10. Then in the next line, then we use the model dot prediction to get the prediction for those points. Is to get prediction from those points. Yes, and let's execute this cell perfectly. We are perfectly executing the cell. And second, and in this cell we can plot our graph. Yes, plot our graph. One first line is used for we can show the real data, and second line is the model prediction line. This line is for model prediction line. Let's execute this cell. See, wait a minute. Yes, okay. And we can see the red line is straight, but data is curved. Yes, but our actual data is curved, and but the red line is straight. So this is an underfitting situation. It goes into the underfitting situation. I think you can understand that what we can do here. This example is for underfitting. Then the main problem is how to reduce this problem, how to reduce the underfitting problem. This is the main point of this is the main question of today's lecture. Let's see how to reduce our underfitting situation. First of all, we can use the first of all we can use the required libraries like first of all we can use a polynomial features. Second one is pipelining pipelining libraries. Uh, in this video, only see what is an polynomial and what is an pipeline. I am not explaining what is a polynomial and what is in pipelining. In a further videos, we can go in a depth what is a polynomial and what is in pipelining used for. Is first of all, in this video, let's see only how we can reduce the how we can reduce the underfitting. Yes. In a further video, we can go in a further video. I can explain what is an polynomial features, what is an pipelining feature. Yes. Let's only see in this video what how to reduce the underfitting situation. Yes. Yes, we can import the requirables, we can execute this cell, and now, now instead of focusing a straight line, we allow the model to learn the curve. Yes, to allow the model to learn the curve, and the polynomial features simply helps to model to learn the curved relationship. Yes, yes, and we can use a linear regression here. Yes, we can execute this cell. Yes, and pipelining just combine the both step cleanly. Yes, that's a simple example of that's a simple explanation of polynomial and pipelining. But we can go in a further video. We can explain that. I can explain that what is an polynomial features and what is a polynomial and what is an pipelining. Yes, we can execute this cell. Yes, perfectly. Execute this cell, and we can go for further. We can fit our model x and y here, and this code is for plotting our graph. Yes, and we can use here. We can plot our graph. Yes, see here. Yes, let's see. We can reduce our underfitting. See here. Our model is predicting the correct curve. See, our best fit line is correct fit on actual data. Yes, this is how we can reduce the underfitting situation. If you are not able to understand that code, it's a normal. In a further, we can go in a further video. I can explain what is a polynomial and how to use a pipelining. Yes, this how to use a pipelining. But in a today's in a today's lecture, let's only see. Yes, here we can reduce the underfitting. Yes, in a next we can go further with overfitting. Yes. First of all, we can take the overfitting problem and we can import our required libraries. We can use a decision tree regressor. Decision tree are very flexible model. They fix a very complex pattern also. Sometimes too complex also. Yes, we are doing a same as above. We can doing a same as above. Yes. You can take a line space and this we can reshape that into a column section, and we can use a decision tree regression for model. We can feed that x and y into model. We can execute this cell decision tree, and this code is for plotting. Yes, same as above. Yes, and the main point is this the graph. Yes. Notice how the curve bends too much. It's it's try to pass it's try it tries to pass through every point. This is called as a overfitting. Yes, this is called an overfitting. See here, the all curves are passing through the points. This is called a overfitting situation. Then how to reduce this? There are some minor changes, some minor changes. Instead of we can decision tree we can give us some parameter max depth we can give a 2. Yes, then we can execute this cell. Yes, now we can see, now we are limiting now we can limiting how depth the tree can grow. Yes, in a decision tree we can grow our depth also tree. This reduce its complexity. The curve becomes smoother here. See, here. Curve becomes smoother. Over Overfitting is reducing. This how we can reduce the overfitting. Yes. As in further video we can also see what is a decision tree, but I'm not but in this video I am not able to explain in depth what is a decision tree because we are not seeing a decision tree. This why. Let's only see in a further video we can go in a depth what is a decision tree, what is an uh, and lot of things we can see. Yes, first of all, only see how overfitting happen and how we can reduce the overfitting. Yes, this is okay. So today we can clearly understood that how to reduce the underfitting and overfitting in machine learning. Yes, when a model is too complex, model is too simple, it cannot learn the pattern properly. This is an underfitting, and we can reduce it by increasing model complexity. Yes, and when a model is too complex, it memorizes the data instead of learning the pattern. This is called an overfitting. We reduce it by simpling the model. Yes. So machine learning is not about making the most powerful model. It's about the finding the right balance between the bias and variance. Yes. And remember this, the too simple underfitting, too complex is overfitting, and balance is a good model. In the next video, we can move forwards and understand the difference between regression and classification problem. Yes, this is a main video. We can see in that video what is the difference between regression and classification, and also we can see one example of classification problem and continue to building our machine learning foundation. Yes. If the video is helpful for understanding the concept clearly, do not forget to like and subscribe to my channel. Yes, let's see you soon in the next video.